Welcome back, everybody. This is example 2.4b. This is kind of a series of little examples that we're doing on acceleration, or that is using all of the equations for kinematics, which of course includes acceleration. So here we got a car that's coming to a stop, and it's leaving a pretty long set of skid marks, so I'm going to assume this is some sort of a sports car, something like that. So here's our sports car, and here it is way down the line right there. Okay, we'll put some tires on this thing, and it wow, the tires are really not centered at all. How about that? Here we go. And it leaves a bunch of skid marks as it comes to a stop. All right. So what do we want to find out? We want to find out the speed of the car just before braking. All right, so we're told that it says deceleration is 9.00 meters per second squared. Well, what's a deceleration? A deceleration is nothing more than a negative acceleration. You might say an acceleration in the negative direction. So, acceleration is negative 9.00 meters per second squared. Okay. What is that 250 meters? What's that all about? Well, that's our displacement. This right here, our delta x, from there to there. So the car was displaced 250 meters as it was braking, 250 meters. All right, and as we've said before, generally speaking, a rule of thumb is if you have three knowns, that is in kinematics, if you have three knowns, you can solve for anything else. All right, well, this only appears to have two knowns right here. We're solving for our V initial just before it's braking, so we don't know that, obviously. What else could we possibly extract from this problem? Well, what is the car doing? The car is coming to a stop, right? It's coming to rest, and so that means the V final is going to be 0 meters per second. 0 meters per second. Ah, that's what we need. That's the other known that we have. So V final equals 0 meters per second. That's the other piece of the puzzle that we need. Okay? So now it just becomes, all right, what do we have? We have acceleration, we've got displacement, and we've got V final. What are we solving for? We're solving for V initial. Do we have any equations that deal with all of them right there? And I think we do. How about this one right here? This is our final equation, or our equation of kinematics. All right, V final squared equals V initial squared plus 2 times A times displacement. Excellent. Let's go ahead and write that in our problem. All right. V final squared equals V initial squared plus 2 times A times delta x. Good. We just need to solve now for V initial squared, right? So the first thing I'm going to do is I'm going to subtract this whole 2A delta x over to that side. So it'll be V final squared minus 2A delta x equals V initial squared. Then all we needed to do is take the square root of both sides, right? Now we're taking the square root of this whole side right here. So you can't just take the square root of V final squared, take the square root of the whole thing. So that means V initial, that is the speed the car was moving at right before it slammed on the brakes, is going to be equal to the square root of the quantity V final squared minus 2 times our acceleration times our displacement. Okay. Don't forget your signs. Remember your acceleration. You've got a minus out front, but also that acceleration is going to be minus, right? And you've got your displacement, and of course your V final. It's going to be 0 right there. So you might think 0 minus something. Uh-oh, wouldn't that be negative? And then we'd have a square root of a negative. But if acceleration is a negative, then those two negatives cancel out. So yes, we do actually have a square root of a positive value. So I'm not going to solve it for you. You can do that, but you can plug in your values. In fact, I'll tell you what, I'll do this. I'll say 0 squared. I'll plug in our knowns. 0 squared minus 2 times negative 9.00 times 250. Oops. 250, square root of all that is going to equal your VI. Okay? Simple as that. Let me know if you have any questions. Thanks for following along, and I'll see you on the next one.